die is suspected to be biased so that it gives more sixes when thrown than would be expected from a fair die. In order to test this suspicion, the die is thrown 30 times. 10 sixes are obtained. Carry out a hypothesis test at the 5% level to test this suspicion. Well, our null hypothesis would be that the die is fair. The alternative hypothesis, in this case, is that the probability is more than 1/6 because we're expecting more sixes than we would get from a fair die. Now what we need to do is define the critical region for a 5% test. Here, the number of sixes obtained would be a binomial distribution with 30 trials and a probability of success of 1/6. Now, I've already calculated some values on my calculator, and greater than or equal to 9 I found was 0.0505, which is a bit more than 5%, so that's not going to be the critical region. But when I went for 10, that gave me 0.0197, and that's less than 5%, and therefore the critical region is from 10 upwards. So the actual significance level for the test is actually 1.97%. Now, we're told that we got 10, and that's in the critical region. So 10 is in the critical region, and therefore we have reason at the 5% level to reject H0.